Okay, so now our last presentation before our break will be Rene Gortat and Doug Young from Leerform in Brooklyn.
Hi, my name is Rene. I'm the co-owner of Leerform. We're a fabrication and design studio in Brooklyn. My role at Leerform is to figure out how to get things done. I would like to start off by showing you a video of Victor, a 4,000-pound crystal, and how we use our 3D scanner and 3D modeling software to create a custom mount, display, and crate.
Meet Victor, a 4,000-pound white quartz crystal from Brazil. He is remarkable, beautiful, mystical. Also massive, asymmetrical, and unbalanced. Creating an attractive display and durable transport crate custom-made for Victor required creativity and technology as amazing as he is. We did it with 3D scanning in 2 phases. The first, to design Victor's metal mount, and the second for his display. Victor's physical composition presented a host of challenges to overcome. Since scanners generally cannot pick up transparent, shiny, or black surfaces, we used an opaque, self-dissolving sublimating film to perfectly capture the unique shapes of Victor and his mount. Because Victor is large enough that one complete data file would be prohibitive, we used markers placed on Victor's surface to scan him in sections, then connected the images together using Einscan software and mapping technology. Also, for data economy, we scanned only the portions of Victor needed for his custom fabrications. To design these items, we imported the scan file into 3D modeling software. Finally, using a CNC machine, we cut wood for the display and crate to fit Victor's specific contours. Now Victor is ready for safe travels and glorious presentation.
That video was a great overview of the project, but I would like to go into more detail about the mount making process. So here's what the scan looks like in Shining 3D. We use this program to do the initial scanning and some of the editing. Now obviously this is not a complete scan of the crystal, because as explained in the video, we only decided to scan the sections necessary to create the mount. We did this because the 3D scan files get extremely large. You can see that this scan alone has nearly 4 million triangles stored. This is a very detailed scan. If we zoom in, you can actually see the sticker markers that we applied to the shiny surfaces of the crystal to facilitate the scanning. The 3D scanner works by recording the position of unique shapes in space and uses them as a reference to record other unique shapes, essentially building a web of points, known as a point cloud. One of the challenges we faced was placing the straps out of the way for scanning while rigging the crystal. Here you can see some of the straps got in the way, so let's delete them before we export the scan. We will save the scan as a OBJ or STL file type and open it in Rhinoceros 3D. So now that we have the file open in Rhino, we can build a mount that fits the scan perfectly. I chose to create a heavy-duty mount using thick gauge 2x2 square tubing to support the weight of the crystal. From here, I created a detailed cut sheet that included lengths and angles and precise placement of the supports. As a result, the completed mount needed minimal adjustment for a perfect fit. And here's a video of another 3D scanning project. The goal was to create a custom dress form out of CNC'd foam. Okay, so we are back in Shining 3D. This is the scan that I was taking in the video. The reason why I chose to 3D scan a person rather than finding a model online is because I was looking for a very specific size for the dress form. And here is the edited form. The bottom portion of the form was adjusted to accommodate the dress and help to retain its shape. In order to create the form out of foam on the CNC, the form had to be spliced into 2-inch layers, which is the thickness of ethafoam. The individual pieces were then arranged to fit onto a piece of ethafoam and saved as an OBJ file. It is then open in VCarve. I use this program to set the toolpaths for the CNC. From there, we glued up the foam and were able to create a size-specific dress form. Thank you for watching. If you have any questions, I'm here to help.
Hello.
Hi.
So for the crystal, was there any mechanical attachment, or were you just relying on the weight of the object itself to keep it honest?
There was no mechanical, it was just a weight, so we just created the mount kind of to fit into very specific points, and then the weight of it just
So the facets of the crystal were engaging brackets that kind of locked it in place, and we did use set screws to also kind of lock it in place.
We have a virtual question. Could you elaborate on the opaque, self-dissolving, sublimating film?
well, I don't think it's an archival thing, but it just allows the 3D scanner to pick up on the surface. So if it's a shiny surface or if it's a very uniform surface, the 3D scanner just can't pick up any unique attributes. So the film, the spray-on film, just kind of shows the surface a little better. So it eventually kind of evaporates. So this is something that I would definitely not use on artwork. It definitely worked on the crystal, but yeah.
And just to clarify, you didn't see the film in that short presentation, so it's not like you missed anything, but we just wanted to mention that because it is something that's used quite often, and it's useful. It's a useful tool to have.
Does it have a trade name?
The film?
Yeah, the film.
I don't, there's different kind of products out there that you can use besides the film. There's dry shampoo, talcum powder that you can put on an object to create an opacity. The film that we use that dissolves, I don't remember the exact name of it, but there's only a handful out on the market for 3D scanning, and just Google it, it's easy to find.
My question was, for the mannequin project, what software did you use for your CNC cutting?
So which software did what?
What software did you use? You went from Rhino and then you pathed it and cut it in
Yeah,
what
so
software?
the program is called VCarve, and that's what we use to kind of set all the tool paths for the CNC.
And how long was the cut time for the mannequin?
It wasn't too long because the foam is, it's very easy to cut through, so you don't have to cut a little bit at a time. So for a full 24 by 96 inch sheet, maybe it took 2 hours, maybe a little quicker.
And if you don't mind me asking, when you're usually cutting foam, how do you dispose of all of the extra?
What do you mean?
Like, do you just like The reason why I don't particularly like using the foam, it's thick and it'll give you the part, but there's so much waste. And this, although CNC is really great, but there is a large amount of waste. And
Sure.
I do
So-
care about the planet.
Yeah, I mean, we try to reuse the foam as much as we can. So we also do crating, which means that we can, cut it down to small 3.5 by 3.5 inch blocks that we use for bumpering out the crate. So we kind of try to use as much of it as possible.
Okay, thank you.
I have two questions, actually. I'm curious about the adhesive that you're using to laminate the ethafoam once it's been carved. And if you have a general idea of, I know that it's about 2 hours to cut the ethafoam on the CNC, but from the time that you scan it to the time that you finish it, the whole process, do you have an idea of how long that was?
I mean, it's fairly quick. So we, let's say it took about 2 hours to cut. We just used hot glue to glue it together. This was an experimental thing that we did, and it worked out beautifully. But gluing it up and doing that probably didn't take more than a day, so it was pretty quick.
Right, and that includes the scanning and all of the sort of software work as well?
Yeah, so yeah, it's pretty quick. And that's kind of what we're hoping to solve the problem of creating unique shapes and being able to replicate them quickly using foam.
The scanning process only took about 15 minutes, and what I think the longest part of that project was building the crates. So the idea is the crates are built the old-fashioned way, and however, there is all this digital fabrication technology out there that can make things a lot faster. So most people in costume world carve ethafoam, by hand, build up blocks, carve it, and then cover it. This was kind of a case study to see how much quicker that process can be. And generally to carve something, and this is also extremely specific. The challenge was to have this form fit a dress that was a very defined shape, and do it in a way that would meet a budget that the museum had. So everything worked out well in that respect. If we were to do this the old-fashioned way of carving out the foam, I don't know, that probably would take a day versus the 2 hours of just assembling it, right?
Right, so the time frame is including the fabrication of the crate and everything, so it isn't just generating the ethafoam part.
So the crate probably took about 8 hours to build.
Okay. Sorry, I was just trying to gauge because we provide body forms for our clients, and I'm always curious about, the old-fashioned way of hand carving it versus making the investment as a business into that kind of technology. How does the timing actually, once you do the scanning, once you do whatever you have to do on the technology side, and then the carving and the laminating, but if it's only like 2 hours, that's pretty incredible.
Yeah, so like this from the scanning to putting that information into the CNC machine to then taking the cut pieces and gluing them together, right? I would say all of that is total about 4 hours.
Okay. And then does your mannequin have any coverings on it, or is it just sort of a smooth ethafoam?
So it was covered in the stockinette, and that was and there was also polyfill in there as well. And that was probably like another hour or so.
Okay. Sorry, I was just curious.
No problem.
So on the crystal, is there a reason that is there a reason that you wouldn't just take a tape measure to it and an angle finder or something? Is there a reason to scan it as opposed to a more traditional measurement taking method?
Well, we didn't have to be under this very large hanging, because we had it hanging in the shop. So it was just a little safer, I would say, and it made our lives a little bit easier.
It's far more accurate,
Yeah.
right? And so part of what we wanted to do is capture specific facets, and we knew that capturing those and bracing around that would lock the piece in. And there was probably about 5 of those points that we needed to capture and fit it within a footprint that was less than the overall footprint of the crystal, to then build the wooden structure around that. So one could do that with tape measures and measuring, but again, the time it takes to scan it and then design the metalwork in Rhino, and then everything's just done on the computer, and then you just cut it up and assemble it. Just so much faster and easier.
We have a virtual question. Did you apply an interface between the mount and the quartz?
There is some neoprene,
Yep.
but that was about it.
And then was that pedestal affixed to the deck or
So
a plinth? Or?
it is, and because the goal, similar to the Edinburgh project, was to have a plinth that was always part of the crate. So you remove the walls of the crate, and there are supplemental walls that you put along the pallet area of the crate, which then covers the skids and creates a presentable plinth solution.
A further question about the neoprene. So if you're picking 5 points, I'm assuming you're assessing the load on each of those points given the metal that you're using. So then does that inform the thickness of the neoprene that you're using? And then also, how do you pick those 5 points given quartz, let's say at that size, nature, possibilities for fracture and things like that, hot spots when you're traveling it over time, how did you pick the points so that you're not potentially creating something that's going to eat the crystal?
Eat the crystal, meaning like wear away at it?
Shear,
right. So the neoprene was 1/4 inch, and it just seemed like a good number to use. The points were decided upon because there was, you can't really see it in there, but those were natural kind of isolated facets that were easy to grab onto and worked well within this footprint. So we want to have these U-shaped brackets, grab the facets, and then go straight down in a linear fashion to the floor of the plinth. And we just chose the ones that seemed natural. So the idea of load bearing, it was 1/4 inch steel tubes. We felt good about that. There was no real calculations that were made other than what physically works within this footprint, these kind of restrictions we were putting on ourselves.
We have another virtual question. We have actually several. But so do you ever have to do a dry run with an object? Once you've scanned it, it doesn't quite work. Do you have to do a prototype?
So for the crystal, it went pretty well. We welded up the mount, and I think it pretty much fit right away. We did have that neoprene, so we had a 1/4 inch. I think in some points we added another little bit. So as far as it fitting, it fits pretty well. We've also, this was not a part of this presentation, but we started 3D scanning objects as a whole and then 3D printing them and making mounts to them. And that also kind of fits so that we essentially just bring the mount in and it fits right away. But I think, we think about that as far as designing the mounts and leave a little bit of room here and there, just if we do have to adjust.
We have more virtual questions, so I'll ask another one. How is the mannequin attached? Wait, let's see. What was used as a stand for the mannequin form? How is it incorporated into the ethafoam component, and how is it attached to the deck?
So there was a T-bar going through the mannequin, kind of through the shoulders down to the floor, and there was just a flange going right into the deck, which was very stable.
Yeah, and this mannequin was strictly for transportation. It wasn't for display.
I was just a little interested in the branding of the scanning tool that you were using. And the first software that you imported that information into, is that connected to that product?
Yeah, so is it INEX?
Einscan.
Einscan, and the program's called 3D Shining, and it's the same company that makes both, and yeah, they're pretty.
You buy the scanner, you get the software.
Yeah.
It's super easy.
Yeah, and they're very good about updating and coming up with new solutions. So every month, there's some new something new they can come up with. Like a while ago, it was very difficult to scan something that was very dark or something that was very light. And just by experimenting, they figured out that if you just adjust the brightness in the 3D scanner and have a certain kind of background, you can actually use the 3D scanner to do that. So they're very good about figuring out these little problems.
About one more virtual. Was the foam finished with anything, or was the CNC cut quality good enough?
So it was finished. It was covered in the stockinette, the nylon.
That's what I thought you had said. Okay.
Mm-hmm.
Thank you.
Before you brought up 3D scanning an object to make a mount to the object, separately, not your presentation, how would you find like the weight or the balance point of an object that you just scanned?
I guess experience with the crystal, we had to rig it up to be able to get under it. So we were able to figure out where the center of gravity was. So that, yeah, I think that was the point. So the 3D scans kind of let you see the general shape, but yeah, you do need to kind of work with the object to figure that out.
Yeah, hi. One question about the foam. When you cut or shape the foam, what kind of density can you use? Which is the softest that you could use?
So this was 2-pound ethafoam, or no, 4-pound.
How much, sorry?
Excuse me?
It was 4-pound ethafoam.
Yeah.
And the harder, the better. If you start getting soft, I don't know why you would, but like ester foam, you can't really carve it. It doesn't work well with,
it tears out, yeah,
with the blade or the bit. But you can cut cavities fairly well with ester foam, so you can carve holes into it, but not really shapes out of it.
What was the total production time for the crystal?
So the one thing no one's talking about is the wood structure behind it, right? So that was the majority of the time spent on that project. And that's where the real problems were. And why that was because there were so many layers, and the layers were being assembled by hand. So you had to deal with the human element, which was prone to failure, right? So if we were able to do that with like a robot, it would have been far quicker. But answering the question about the dry run, that went through many dry runs to get everything to fit. And then, once you get it up to here, it's still not quite right, so you have to start all the way at the bottom again. So, it took about, I guess, 2 weeks to do the whole thing, and that includes building the crate.
What kind of cutter did you use for the foam?
What kind of cutter you said?
Yeah, how many flutes, that sort of thing?
It's I think a 2-flute 1/4-inch bit, and it's pretty long. It's like I think 3 inches long. No. Oh, you mean the bottom? It's an end mill. So yeah, it's square at the bottom. Yep.
Okay, thank you.